Hi, I'm Dave Maynard, and in this session we're going to talk about another philosophical argument. It's called the teleological argument. Teleology just means design, so you could say this is the design argument. Again, before going on and listening to the rest of this, I'd really like you to take a few minutes and watch the YouTube video, and that's in your notes where it is. That'll explain the teleological or the design argument really, really well. So please listen to that, then come back and listen to the rest of this. Okay, I want to give you a little history first, because a lot of people think that science and religion, or really science and Christianity, have always been at war with each other. And that's not true. That didn't happen until the late 1800s. And even then, it took it a while to really seep into the scientific community. Before then, science was always seen as the handmaiden of Christianity. Almost all the early scientists in the modern scientific revolution were Christians, and they defined their discoveries in Christian terms. 7 of the 10 founding members of the Royal Society of London, which is arguably the most prestigious scientific organization in the world, 7 of those 10 founding members were Puritans. And I believe the other 3 were Christians also. I'm not sure of that, but 7 of them definitely were. So how did this war start? Well, in 1874, John William Draper, a scientist, published a book entitled History of the Conflict Between Religion and Science. Like I say, up to this point, you hadn't heard about there was no real conflict. In 1896, Andrew Dickinson White, the president of Cornell University, and to my knowledge not a scientist, published a book called A History of the Warfare of Science with Theology in Christendom. They both taught that science and Christianity were at war with each other. And like I say, up until this time, science was seen as the handmaiden of Christianity. Almost all scientists since the modern scientific revolution were Christians or expressed their discoveries in Christian terms. One of the things I like best is that over time, science eventually comes into agreement with the Bible. So faith and science are both quest for the truth. Since we're going to look at where the universe now we're going to look at where the universe comes from and how fine-tuned it is for life. Now, the Bible teaches that the universe had a beginning. Until the mid-20th century, science taught that the universe had always existed, and that was in direct conflict with the Bible and with philosophers. But in 1929, American astronomer Edwin Hubble, and yes, that's who the Hubble Space Telescope was named after, discovered the red shift of distant starlight. Now, I'm not going to get into what that is, but basically it meant the universe was expanding in all directions. Then in 1948, scientists began to conclude that the universe came from a single point and it expanded outward. This was confirmed only in 1964 with the discovery of the cosmic background radiation. And again, I won't get into that, but that is just the initial temperature of, that's the temperature of the universe. The conclusion was that all matter, energy, and time came into existence at the same point. And they call that the Big Bang. J.M. Wersinger, professor of physics at Auburn University, has said this, quote, "At first, the scientific community was very reluctant to accept the idea of the birth of the universe because it seemed to call for a supernatural creation. It took time, observational evidence, and careful verification of the predictions made by the Big Bang model to convince the scientific community to accept the idea of a cosmic genesis," end quote. Scientists don't like to think the universe had a beginning, because that may imply that there's a beginner. They don't like to say the universe was created, because that implies the universe had a creator. Even now, the 13.7 billion year age of the Big Bang is generating some serious problems for scientists. Many are now questioning the Big Bang model, and some are coming up with different models. One such model is Dr. John Hartnett. His model is even more in line with the biblical time limits. But there are still scientists who are trying to get around this idea of a creator. And one such attempt is the multiverse model. What is the multiverse model? Well, it's like there's this universe creating, I'll say machine, it's not a normal machine. There's a universe creating machine out there that is spitting out bubble universes all over the place, just at random, by chance. And by chance, it happened to spit out our universe, which was, by chance, very suitable for human life. There is absolutely no observational evidence for this. None. Zero. It is, some scientists, it is their pipe dream to get around the evidence that our universe was created. They want to get around the creator. And it just goes to show how far some scientists will go to not accept the evidence of a creator. Now, the teleological or the design argument goes like this. A, all complex systems imply a designer. Now, by complex systems, I don't mean simple designs or patterns like a snowflake. I mean really complex things like DNA. For example, if you're walking in a forest and you found a watch, you would assume that the watch was made by someone. Good assumption. You wouldn't assume that that watch just evolved over billions of years and it evolved from the Earth's chemicals or the materials in the ground. You wouldn't assume that. You'd assume it was made. Why? Because it's designed. It's a complex piece of equipment. So the second thing is, there is great design in the universe. For example, the information encoded in the DNA. Wow, that is, when you really get into that, that's mind-blowing. Or the physical laws of the universe. The law of gravity, you know, the electromagnetic laws, the structure of the atom. And even now, we're finding out, we're not 100% sure of the entire structure of the atom. I mean, what makes up a proton? What makes up a neutron? Well, you know what makes up a neutron, but what makes up a proton? What makes up an electron? You know, we're finding things out like that now. So and the third thing, part C, is that since there is great design in the universe, therefore there must be a great designer. William Paley made this argument like 300 or 200, between 200 and 300 years ago. And it was very powerful then, and it's coming back into vogue even right now. On my website, I have a lot of quotes from scientists who are saying, wow, the more we're discovering about how fine-tuned our universe is for life, we can't get around that there is a designer out there that designed it this way. To fully understand the implications of this argument, you're going to need to understand some math. Yeah, exponents. Oh, the joy that must be coursing through your veins right now. Okay, I get it. But this will be fun, okay? If you pull out the sheet that I have that explains all that, I'll go over it quickly. The number 10, if you express that as an exponent, it'll be 10 with a 1 to the upper right of the 0 as a superscript. So 10 to the first power is just 10. 10 to the second power, that would be 10 times 10. Or 10 to the second power, or 10 squared. What is 10 squared? It's 10 times 10. What's 10 times 10? It's 100. So 10 squared is the number 1 with 2 zeros behind it. 10 to the third power, or 10 cubed, is 10 times 10 times 10. 10 to the third power is the number 1 with 3 zeros behind it. What's that? It's 1,000. 10 times 10 is 100, times 10 is 1,000. 10 to the sixth power is 10 times 10 times 10 times 10 times 10 times 10. That is the number 1 followed by 6 zeros. So you see that whatever the superscript is, the number is going to be 1 followed by that many zeros. 10 to the sixth power is 1 followed by 6 zeros. That's 1,000,000. 10 to the ninth power is 1 followed by 9 zeros, and that's 1,000,000,000. 10 to the 12th power is 1 followed by 12 zeros, and that's 1,000,000,000,000. After that, I don't believe we have words to express. We may have 1 or 2 things beyond that, but usually people stop at 1,000,000,000,000. Beyond that, they have to express it exponentially because we just don't have the words. One thing I want to point out, though, the difference of one number in an exponent. What's the difference between 10 to the first power and 10 to the second power? Well, it's the difference between 10 and 100. That difference of one number in an exponent is 10 times as much as the previous number. So 10 to the second power is 10 times as large as 10 to the first power. 10 to the third power is 10 times as large as 10 to the second power. Okay? If you have a number 2, if the difference in 2 exponents is, there's a difference of 2, 10 to the first power and 10 to the third power, the difference is 100 times as much. It's just the difference of the exponents. 3 minus 1 is 2. Okay. Guess how many stars are, or at least how many we think there are, in our entire universe. Not our galaxy, but the entire universe, or the observable universe. 10 to the 22nd power. That's the number of stars. That's the number 1 followed by 22 zeros. That's how many stars we have in our observable universe. Guess how many atoms we have in the entire universe. And atoms are these really tiny little things. We're made up of a bunch of atoms. There's atoms all around, in the air, everywhere. Guess how many atoms there are in the entire universe. 10 to the 80th power. That's the number 1 followed by 80 zeros. Numbers like this are way beyond our comprehension. Although, if I say something is impossible, the word impossible is really hard to define, but scientists have come up with a definition for it. If you don't have one chance in 10 to the 53rd power of something happening, it will never happen. So if you don't have one chance in the number 1 followed by 53 zeros, it'll never happen. Now, in a lottery, we might say, hey, you got one chance in 1,000,000. Well, that's one chance in 10 to the 6th power. Or one chance in 1,000,000,000. That's 1,000 times one chance in 1,000,000. That's one chance in 10 to the 9th power. This is zero possibility of happening, means it will never happen. No matter how long the universe exists, this will never happen if you have one chance in 10 to the 53rd power of it happening. Okay, that's all we're going to do for exponents. Now, I want to talk about, with that in mind, I want to talk about some of the constants in the universe, like the strength of gravity. Gravity is just the force that one body draws another body to it with. We experience gravity because our bodies are being drawn to the earth. Okay? So there is a strength to gravity. If you change that strength by 1 part in 10 to the 40th power, stars would never have formed. Why? Because gravity wouldn't have been strong enough to pull all the particles together. If you change the rate of expansion of our universe, now our universe is expanding, we know approximately how fast it's expanding. If you change the rate of expansion of our universe by 1 part in 10 to the 12th power, the universe wouldn't even have formed at all. I mean, it just wouldn't have expanded. It would have stayed in this tiny little point. If you changed the strength of the strong nuclear force, now the strong nuclear force is what binds the protons and the neutrons together in the atomic nucleus. If you change that by 1 part in 10 to the 60th power, atoms, that strong nuclear force wouldn't hold the protons and the neutrons together. They'd fly apart. And if they fly apart, nothing would, we wouldn't exist, the table wouldn't, nothing would, planet wouldn't have existed, nothing would have existed. That precision of the strong nuclear force, that precision is the same, 1 chance in 1 part, changing it by 1 part in 10 to the 60th power, that chance is equal to the precision of firing a bullet from a gun and hitting a 1-inch target at a distance of 20 billion light years. 3, 4, 5, 6, 7. That is the 1 chance in 48 followed by 22 zeros miles away. That's impossible. You're right, it is. If you combine all 3 of these constants together, what are the chances that those constants would have formed just by pure chance? Well, you add the exponents. You'd have 1 chance in 10 to the 112th power. That's 1 chance in the number 1 followed by 112 zeros. Now, 10 to the 53rd power is impossible. 10 to the 54th power is 10 times impossible. 10 to the 55th power is 100 times impossible. 10 to the 112th power? We're not even talking there's a 0 chance. This is, you can't comprehend it. Now there's astrophysicist Dr. Hugh Ross has identified 122 of these constants that are in our universe. The probability of any planet in the universe existing by pure chance, with all of the conditions for life that we have, is 1 chance in 10 to the 138th power. That is the number 1 followed by 138 zeros. Since there are only 10 to the 80th power number of atoms in the entire universe, we're saying that there is way beyond a 0 chance of any planet forming with all of the life-supporting conditions that we have here on Earth, unless there is an intelligent designer, and an all-powerful designer, and an all-knowledgeable designer. Nobel laureate Arno Penzias has said this, quote, "Astronomy leads us to a unique event, a universe which was created out of nothing and delicately balanced to provide exactly the conditions required to support life. In the absence of an absurdly improbable accident, the observations of modern science seem to suggest an underlying, one might say, supernatural plan. End quote. Cosmologist Ed Harrison has said, "Here is the cosmological proof of the existence of God. The fine-tuning of the universe provides prima facie evidence of deistic design." These constants all define what is known as the anthropic principle. That is the mounting evidence that many scientists believe that our universe is so extremely fine-tuned or designed to support human life on Earth. If that's the case, there must be a designer. Life being created by chance takes a lot more faith than it takes to believe it was created by God or by this first uncaused cause. Again, at the end of your notes, I've listed several websites and books that go into much, much greater detail about the teleological or the design argument. That's it for now, and we'll see you at the next session. Bye-bye.